So some of the mutations have also probably causes adverse effect on the virus, so that it reduces the infectivity, or it reduces the transmissibility of the virus. But this mutation also has this deletion of spike 67 and 70 amino acids. So that has caused increase in binding. So that has overcome the negative effects of all these, some of these mutations, and has emerged as a stable variant that has survived for a few weeks or about a couple of months. That's what people think. The researchers think. So how this all happened was, in the UK, there's a lot of testing that's happening now. There have been what called as lighthouse labs. This is community testing on a mass scale, where tens of thousands of tests are done in mainly 4 different labs in the country, but samples come from all over the country. So several thousand samples are processed every day, and there they found that there have been what's called S dropouts. So in the PCR, as I explained last time, we look for a specific gene site to detect, to amplify the virus and detect that part of the genome. So PCRs can use only one. Even you can use only one site. You can use 2, or in the UK, MHRA very early on in the pandemic said there should be at least 2 regions for a test to be used in the UK. At least 2 regions should be amplified by the test for it to be approved in the UK. So most of the tests have at least 2, or many of them also have at least they have 3. So in the lighthouse labs, they were using primers or the tests which detected 3 different regions of the virus: the ORF1ab, S for the spike, and N is the nucleic acid. So what happened was they suddenly started seeing in about October time, mid-October time, there were some changes in, or the results were, the PCR results were very strongly positive in 2 of them, the ORF and the nucleocapsid, but not on the S. The S was completely negative. They couldn't detect anything on the S. So they called this S dropouts. These changes can happen. These kind of results often happen in the labs. So they had to wait and see till they get a few of them. If this was a constantly happening result, then they wanted to wait and see. And when they found out that by about early November, they were quite confident that they were seeing completely something very different here. And then they were able to analyze the whole genome sequencing, the COG and the Sanger Institute. Together, I sequenced about 8,500 samples of these S dropout, with the S dropout status. And there they found that there was a deletion of amino acids 69 and 70 in the spike gene. So that's how it was detected. So that's why it takes a few weeks with all a very good setup to confirm that there is change, and then find out what actually that change is. So this is just again the dendrogram to show the various lineages. That's actually the site spike N439K. So this K was not there, so there is a change. That's the change. There's a bonding. I'll tell you that. Just as we are here, I'll just mention this. This is another mutation that has been detected. This news also came very simultaneously a few days after the UK announced that there was a new variant. South Africa announced that they have found a new variant, and that was called as Y453F. Again, a spike change in the spike protein composition. Again, a small change. We'll talk about that in the next slide. So this is how, on the right side of the screen, you can see that that is the spike protein. So you can see this is the model, but you can see that there are lots of blobs there. So each blob representing a protein component. So here there are the small circles, and this is the 439, which is the original one, which there was a change because of the mutation. So this is these regions in the spike protein which bind to the ACE2 receptors of the human cells is called the receptor binding motif or receptor binding domain, RBD or RBM. There, RBD is a bigger region, this whole region, but this little, if you talk about, if you just about this 439, that is called the RBM. That's the motif. So there are several such motifs which help to bind. So when a virus binds, a spike protein binds to the receptor, it does not attach on one single point. It attaches several points, tens of a dozen points, say about a dozen points. So each of them are called a motif, and any change in that can cause some changes in how they bind. So because these receptor motifs, there are lots of them, and they're highly plastic, so they can change quite a lot because there's a lot of room to change. So that's the molecular analysis. That's fine. So so this is about the new UK strain. So there are multiple spike protein mutations that have been identified. These are the ones which are highlighted in the blue color. Those are the changes that have been identified. But some of them have actually, because there may be dozens. I don't know exactly the number, but there are several numbers of points which attach to the receptor, and actually some of these changes would have caused the virus to be less effective, but because of this 6970 del, they call deletion, or this 439 change, that has caused the spike protein to bind to the receptor much better and much more snugly, much more intensely. So that's the chain, and then so that can cause. So what they say is that there was no bonding between these two regions. So there's a salt bridge that has in the new variant. You find that there is a salt bridge from one motif to the other motif, which can cause it to bind to the receptor better. So that is the basic change that has happened. So similar changes happened with the South African strain. It is on a little different site, a little further away from this region, but the two are very similar. The molecular basis is very similar. So just to conclude, SARS-CoV, it came in as a ready to go, adapted to human population. Somehow it changed in the bats, and somehow it got into that. It was a generalist virus which evolved in the bats, but then genetic variation is accumulating, but very slowly. That's what we should remember. It's accumulating, and it will accumulate. There's no surprise. We always knew it was going to happen, and we in March, most of March and early April, we were expecting it to change so much more aggressively and faster, but that has not happened. So some of the changes may cause antibody escape and all that. This is all being discussed in the research groups. There may be changes, but the there's a relatively stable amino acid change in the current strain. This is the first time that there has been a stable change in the last 9 months. So what we will be worried about is vaccine escape or immunity escape in these variants. So what are the implications of this? Use a few more slides just to summarize very quickly. So a bit more detail on the test. So unless a test is using only spike protein component or the genome coding for the spike protein component, if you're using a test which only has that, your test will be false negative. At least in the UK, I know, and I think even FDA in the US has mandated that there should be at least 2 targets, or usually companies have gone for 2 targets, some have used 3, and one of which could be spike. Then your test will not be false negative. So don't think, if you're worried about false negatives because of this variant, check with your lab what they're doing, what is the target they are looking for. If they're looking for spike protein only and nothing else, then you're bound to get false negatives. If they're using ORF along with the spike protein, or N, the nucleocapsid with the spike protein, or the membrane the component with the spike protein, these are the typical combinations, then you will not get false negatives. And many tests also use 3, as I said, as I gave the example in the Lighthouse Labs in the UK. So they use 3 regions. So there is no question of getting a false negative. So if you're worried about false negatives, you check with your lab. If your lab is using another component apart from the spike protein, your test cannot be negative. So the antibody binding site, actually with this variant, the antibody binding has become better, would probably be better, because there is no change to the binding capacity by binding of the antibody with the spike protein. But there are more work that is being done. But currently, what the information that we've got is there is no change to the binding. So if you're using any antibody test, that should not be affected with this variant. So treatment, because we don't use much treatment, there's no treatment issues at all with this variant. Vaccine, again, lot more work has to be done, but there is nothing anticipated that this virus will escape this current vaccine, whether it is the Pfizer or the AstraZeneca that's going to come to India. I think the Oxford AstraZeneca one, which is being produced by Serum Institute, I think is going to get approval sometime this week, which will also be approved in UK, we are told this week. So both these vaccines and the Moulded vaccine, which is being rolled out in the US, all of them will cover this variant. There is no change in that, but the research groups are studying it further, and the vaccine manufacturers have the capability to change the antibody production, or the vaccine production, to suit the change, if there are any changes which will come in future. It's not about this variant, but in future, if we get any changes in the virus structure which need a change in the vaccine companies can do it very quickly. It doesn't take too long for them. So all the technology is there. So we've been reassured about that. The only change for both the South African strain and the UK strain the new variant, the UK variant and the South African variant, is that it's probably more transmissible. I know more about the UK strain. It is more transmissible by 50 to 70%. But look at the thing. When I went into the details, I was a bit surprised. There are also reports that it's only transmissible about 40 times, 1.4 times more than the original virus. But all the news media, everybody picked up 70%. They went for the highest one, not the lowest one. So I always get surprised by how people pick what they want to scare everybody and not see reason and understanding. So transmissibility is definitely an issue, which probably could be for an advantage, because more and more people who are healthy may be infected, and the herd immunity could be achieved more quickly. That's my personal opinion. But it may not always be bad. If it's more transmissible, the pandemic will probably end quickly. If the doubling time increases, hopefully the pandemic will finish off very quickly. Infectivity, there's more better binding to the ACE receptors, and probably the infectivity is a bit higher, and that's why the transmission is probably higher. There is no change in pathogenicity. It's only the spike protein that is changed, only the binding that's more snug now and more better. So other aspects of the pathogenicity has not changed. The severity of the disease has not changed. The mortality has not changed. So none of them have been. So this is observation for more than 2 to 3 weeks now, or nearly 6 weeks now, in patients in Southeast England and London area. So there are lots of people, about tens of thousands of people have been infected with this strain, but they've not found anything. It's a similar story for the South African variant. The mink variant has not gone beyond Netherlands much at all, although we have all got information about what to do if we get a mink strain, but that variant has not reached UK, hopefully, and it's confined to Netherlands. So that's the end of my talk. If you have any questions, you can always take it up later.
Yeah, thank you, Dr. Krishna Banwati. So excellent lecture, and lot of questions are already answered. So we should go for the question and answer session later. So I think that all the viewers have the clarity regarding the lineage and the mutation and also the variant. So let us discuss later. So now I invite Dr. Ramasya to go for his talk on what is the implications or the prevention or the management part of this mutations. Will any differences are there, or otherwise they are going to disturb the routine protocols? What is their experience in London? So now I invite Dr. Ramasya for his talk. So please share your screen.